Welcome back, Mathcounts friends. In today's video, we're going to be taking a look at the team round of the 2025 chapter Mathcounts competition. Let's go ahead and jump right in. This one says Alex planted 4 times as many tulips as Patrick planted. Okay, so Alex planted 4 times as many as Patrick. So this is 4 times as much. And together they planted 100 tulips. How many tulips did Patrick plant? Okay, so Patrick planted X, let's say, and Alex planted 4 times as many, which is 4X, and altogether they planted 100. Whoops, 100. So 5X is 100, that means X is 20. Okay, that was an easy one. Let's go on to the second one. This one says, all the students on the playground are wearing either long pants or shorts, and some are wearing a jacket. Here's a table where Sarit recorded how many students are wearing various items. What is the probability that a randomly selected student on this playground is wearing long pants and a jacket? Okay, so long pants and a jacket, that's these guys here. What's the probability that you're in this box, basically? Express your answer as a common fraction. Okay, so how many are in there? There's 8. There's 8 in there. And then we need to divide by the total number in all the boxes, which is 8 plus 7. There's 15 wearing a jacket. And then 3 plus 10, there's 13 not wearing a jacket. Altogether, that's 28. So 8 divided by 28, if we simplify that, that's 2/7. So 2/7 is our probability. Let's go on to problem 3. This one says, Shay buys kazoos in packs of 4 for $3, okay, and sells them in sets of 3 for $2.85. If she purchases 60 kazoos and sells them all, what is the amount of her profit? Okay, so first of all, how much is she paying for each kazoo, basically? So $3, that's 300 cents. 300 cents divided by the number of kazoos she gets, which is 4. That's going to be 75 cents that she's paying on average for each kazoo. And how much is she selling them for? So it's 285 cents for a pack of 3. So 285 divided by 3 is 95 cents. So she's basically making a 20-cent profit. 20-cent profit. 20-cent profit on each kazoo. And there are 60 kazoos that she sells. So if we think about this in dollars, this is a fifth of a dollar. So a fifth of a dollar times 60 kazoos is going to be $12. All right, they wanted to know, yeah, you could, I think in Mathcounts you're allowed to write 12 or you can put 12.00. It shows you in the answer blank a dollar symbol showing that you should express your answer in dollars. All right, let's move on to number 4. Well, maybe one quick comment on this. You might have to watch out in a problem like this to make sure that the number that she sells is evenly divisible by the packs that she sells them in. So if it was 61 kazoos, I guess then she wouldn't have been able to sell them all. But sometimes you might have to watch out for something like that. But 60 is divisible by 4 and it's divisible by 3, so we don't have to worry about anything like that. Number 4 says, on Sunday, Ashton buys some donuts. On Monday, she gives half the donuts to Rachel, and on Tuesday, she gives a third of the remaining donuts to Helen. If Ashton has 24 donuts left, how many donuts did she buy on Sunday? Okay, so let's say the number she bought on Sunday was D, and then she gives half of them to Rachel. Now she has D over 2. And then on Tuesday, she gives a third of the remaining donuts to Helen. That's going to multiply the number of donuts she has by 2/3, right? And then after that, she has 24 donuts left. Okay, so we can cancel this out. We can multiply both sides by 3, and we have the number of donuts she started with is 24 times 3, which is 72. All right, let's take a look at the next one. This one says, what is the probability of randomly selecting 3 distinct unit squares on a 3x3 grid and getting 3 unit squares in a row vertically, horizontally, or diagonally? Express your answer as a common fraction. Okay, so how many different rows are there? There's 3 vertical rows, right? So that's 3. And then there's 3 horizontal rows. 1, 2, 3. And then finally, there's our 2 diagonal rows. 1 and 2. So altogether, there are 8 ways that she can get, is it a she? That was the last problem. There's 8 ways that the person who's selecting these can get 3 in a row. And how many ways are there totally total to pick 3 of these 9? Well, that's just 9 choose 3. So if we look at this probability, we've got 8 divided by 9 choose 3. 9 choose 3 is going to be 9 times 8 times 7 divided by 3 times 2 times 1. Okay, now we can start canceling some things out. Let's grab a different color for that. So we're going to cancel this out to give a 3. We're going to cancel this out to give a 4. And then look, this 4 can cancel here to give a 2. And so now what have we got left? We've got 2 on top, and we've got 3 times 7 is 21 on the bottom. So that is our final probability. Okay, moving right along. Doris is twice as old as Boris. Okay, so Doris is twice as old as Boris. This is 2x. And Boris, let's see. Doris is twice as old as Boris and 3 times as old as Morris. Okay, so this is a 3 times up here. All right, and they say if Boris is 8 years older than Morris, how old is Doris? Okay. I mean, when I see these numbers, I just immediately think, well, what's the lowest number that these could be if we just ignore this last bit? And so that's, Doris could be 6, and Boris could be half that age, and Morris could be a third that age. So it could be 6, 3, and 2 if we ignore this constraint. If this was the case, then Boris would be 1 year older than Morris. So this difference would be 1. But we're also told that that difference is actually 8. So we need to multiply all these numbers by 8. And then the question is asking how old is Doris. So it's just 6 times 8, which is going to be 48. That's one way to do it. All right, let's take a look at number 7. This one says, in how many different ways can 18 be written as a sum of positive perfect squares if order does not matter? Okay, so what are all the positive perfect squares that we could use? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. The next one's going to be 25, which is already bigger than 18. So these are the ones that we can use. We just have to figure out how many of each we're going to use. So maybe we can make a table like this. And I like to start with the biggest one. So there could either be, and then I like to start with the highest number of those that we could have. So the highest number of 16s we could have would be 1. And if we had 1 16, we couldn't have any 9s or any 4s, and then we'd just have all the rest to be 1s. I can, just to be complete, I can fill in the last column. You don't actually have to fill in the last column because we just need to count how many rows there are. Okay, so then the next possibility is that there's 0 16s, and let's take the largest number of 9s there could be. There could be 2 9s, which would leave 0 and 0. Or there could be 1 9. If there was 1 9, how many 4s could we have? Well, we could have 2, or we could have 1, or we could have 0. So all these are with 1 and 0 here. And we would be able to fill out how many 1s we would need. I'm not going to bother to do that because it's not necessary for the problem. And so that's all the possibilities where we have 1 9. The next option is that we could have 0 9s. And if we had 0 9s, how many 4s could we have? Well, we could have up to 4 4s. And in fact, we could have any value from 0 up to 4. So once I pick a value here, that'll set the number of 1s I need. So I'm going to count 5. I'm going to, instead of writing out those 5 rows separately, I'm just going to count this one as 5. And then I'll count the rest. We've got 1, 2, 3, 4, 5 up here. So 5 and 5 is 10 altogether. So 10 is our answer here. Okay, let's take a look at problem 8. This one says, Yining writes down an arithmetic sequence of 100 terms. It says the first 5 terms of the sequence are these numbers. What is the sum of Yining's 100 terms? Okay, so the first thing you can look at is, okay, the difference between each adjacent pair is 3. And whenever you want to find the sum of an arithmetic sequence, you can take the first number, I call it the starting number, plus the last number, the ending number, divided by 2. That gives you altogether the average of all the numbers. And then if you have the average, you just need to multiply by the number of numbers, and that will give you your sum. Okay, so in this case, the starting number is 32. We don't explicitly have the ending number, but we know that the ending number is going to be 32 plus 99 threes, right? So In order to get to the second number, you need to add 1 3. In order to get to the third number, you need to add 2 3s. All the way up to getting to the 100th number, you have to add 99 3s. So this will be the starting plus the ending. Then we have to divide by 2. And then we have to multiply by the number of numbers, which is 100. Okay, so what's 99 3s? Let's see, that'll be 297 here. And then we've got 64 over here. 297 and 64, that's going to give us, let's see, 361. So we've got 361 times 100 over 2, which is 50. 36 times 50 would be 18,000. So we've got 18,000 and one more 50. So 18,050 will be our final answer on this one. Okay, let's go on to number 9. Number 9 says Greg has some dimes, nickels, and pennies. He has 3 more dimes than nickels and 6 more nickels than pennies. Currently, the average value of his coins is 7 cents per coin. How many dimes does Greg have? Okay, so they're asking for how many dimes, so maybe I'll just call that X. So X is the number of dimes. And if I want to find out the total value of his coins, I'm going to have to multiply that number of dimes by 10, because each dime is worth 10 cents. And then I'm going to have to multiply by 5 the number of nickels he has, which is going to be X minus 3, because he has 3 more dimes than nickels. And then I have to add the number of pennies. I just have to add 1 for each penny, so that number of pennies is going to be X minus, let's see, 6 more nickels and pennies. So that'll be X minus 9, right? Because the number of nickels was X minus 3, and so 6 less than that will be X minus 9. So this is the total value of all the money he has. In order to get the average value, I have to divide by the number of coins he has. Well, how many coins does he have? He has X dimes, plus he has X minus 3 nickels, plus he has X minus 9 pennies, and we know that that is equal to 7. So this looks a little scary, but it's really not too bad. You can start adding things together and simplifying. This denominator actually just becomes 3x minus 12. That's not too bad. And then we can multiply that onto the other side. So, and we can simplify some things over here at the same time, right? So how many x's do we have altogether? 10 plus 5 plus 1. That's 16 x's on this side. And then we've got a negative 15 and a negative 9. So that'll be minus 24. And that's going to be equal to 7 times 3x minus 12. All right, so this is going to be equal to 21x minus 84. And I don't need this part anymore. So let's add 84 to each side. And let's subtract 16 from each side. So if I do that, I'm going to have, let's see, if I add 84 over here, I'm going to have 60. And then I'm subtracting the 16, so that goes away. But this is going to be 21 minus 16, so that's 5x here. So 60 is 5x. That means x is 12. All right, not too bad. Let's take a look at the last one. This one says, in concave quadrilateral ABCD below, AD is 15. They've given us that here. AB equals BC equals 20. They've shown that here. And then AC is 24. Okay. That edge is not part of the quadrilateral, so they've given it as a dashed line. It's a concave quadrilateral with these solid lines here. It says, if P is any point in the plane, what is the minimum possible value of PA plus PB plus PC plus PD? Okay, so we can put P anywhere, but obviously if we put P out here, that's not going to be good, because anytime we move it in this direction, it's going to get closer to all the points, right? One thing you might recognize right away is that this figure is symmetric. And so P is going to have to be, hopefully you can convince yourself that P is going to have to be somewhere on this midline. Right? So I'm just going to draw like a midline there. P is going to have to be somewhere on there. And if you want it to be as close as possible in average to all the points, or, I mean, the average distance is just this sum distance divided by 4, right? So we kind of want to make it as close as possible to all the points. You're not going to want to have it up above B, certainly, because as you go, say you took P from B and you moved it up, you'd be getting farther away from all 4 points if you moved it up, right? So that's not good. And the other thing is, let's consider all the points on this little segment here. Which one would be the ideal, of those points, which one would be the ideal place to put P? Well, if you think about starting at B and moving down, let's just think about the distance from P to B and the distance from P to D. The sum of those distances is going to be the same no matter where you are on this segment. So when you're picking where to put P on this segment, if you're trying to find the best place to put P on this segment, you wouldn't need to consider the distance to B and D, because that sum is going to be the same no matter where you put it. So you just need to consider the distance from A and C, and quite clearly it's best to go as low as possible. So you'd want to be here at this point D, right there. And now you can start thinking about, okay, what happens if I go even further down from point D? Are things going to be getting better or worse if I go further down? Obviously, you definitely don't want to go below this point, right? So now we've kind of constrained ourselves so that we know that our answer is somewhere on this pink line segment here. Because if you go below this point here, you're just going to be getting farther, the farther down you go, you'll just be getting farther and farther away from all 4 points. So the last thing we need to figure out is where along here do we want P to be in order to be on average as close as possible to the 4 points. So the first thing to think about is, you could think about B and D, right? Every time you move down, let's say 1 unit along this line segment, you're going to be adding 2. As far as B and D are concerned, well, for each B and D, you're going to be adding 1 additional unit, because if you move down 1 unit, you're going to be 1 unit farther away from D, and you're also going to be 1 unit farther away from B. And so basically, every time you go down 1, you're adding 2 to your sum, if you just consider those 2 points. But now you have to also consider A and C. How much closer are you getting to A and C? So as you go down, your distance from A and C gets lower, so that's a good thing. But going down 1 unit is going to get you closer by less than 1 unit. In order to get it closer by exactly 1 unit, you'd have to be going directly at C in that direction for 1 unit of movement to get you 1 unit closer. And likewise for A, if you wanted to get 1 unit closer to A, you'd have to move exactly toward A. And when you're going along this line segment, you're not going exactly toward A or exactly toward C. So that means going down, anytime you go down on this line segment, it's a bad thing. So just based on all of that, we can say that the ideal place to put P is right on top of D. And now we can just compute all those distances, right? So the distance PA, what will that be? That'll just be the same as DA, which is 15, so that'll be 15. And then PB, that'll be this distance here. Let's see, do we have that distance? I guess we need to figure that one out. Let's do that one last. And then PC, PC will be DC, that'll be this one here, that'll be 15. And then PD will just be 0, because P and D are right on top of each other. So the last thing, so this is going to give us 30, and then the last thing we need is this distance PB. Okay, so that shouldn't be too hard. I think we've got 15. What is this? This is 15 here, and 20 here. And let's see, do we have any other distances? We have 24 across here, right? So that means this distance here is going to be 12. So that means we're going to have a right triangle here. Let me draw it in a different color here. So we're going to have a right triangle from B down to the bottom here over to C. And that is also going to be a 3, 4, 5 triangle, because we've got 20, which is 5 times 4. 12 is 3 times 4. And so that means this height has got to be 4 times 4. So that the height all the way from this bottom point up to B, we'll just draw it over here. That's going to have to be 16, 4 times 4. And let's see, what else do we know? We know that we have this other right triangle. Maybe I'll draw it on the other side. It's symmetric, so I can draw it on either side. Maybe I'll draw it in green since I haven't used green yet. We've got this other triangle here. There are two of them, but I'm just going to draw the one on the left this time. It's got 12 here, and it's got 15 here. And so it's also a 3, 4, 5 triangle. This is 5 times 3. This is 4 times 3, so this one's going to have to be 3 times 3. So that means this little height here is going to be 9. Okay, and so that means, of course, that the distance we're looking for, which is here, right, from D up to B, that one is going to be the difference between 16 and 9. So that'll be 7. And then we've got 15 plus 15 plus 7. That's going to give us 37 as our final answer here. Okay, I hope you guys enjoyed this video. Be sure to like and subscribe. Check out all my other videos. I've got the sprint, 2 videos on the sprint. I've got a video on the target. And then I've got a special video on target problem 8, which was a really hard problem. So I hope you guys enjoy all those videos. I'll see you guys in the next one.